In this video I would like to demonstrate how to apply Engle-Granger cointegration, residual based two-step cointegration approach on your data. This approach has been criticized in many papers. Actually, it's one of the oldest ones, and at the same time it's one of the simplest cointegration methods. Now I have this data here. I will now define the variables. I will look at these three variables and I will look at them to see if they are associated in the long run, or in other words they move together in the long run. Okay, now FTSE ADIV, these are the values of FTSE All Share Dividend Index, and these are the values of FTSE All Share Price Index. So these are the All Share Price Index basically, and these are the 20-year UK, I think these are treasury yields. Yeah, I think 20-year UK treasury yields. Now I would like to see if they move together in the long run. If they move together in the long run, in other words, they have common movements. To do that, I will apply the Engle-Granger cointegration technique, and basically this is the simplest technique, as I said. So let's start now. Now to start the cointegration, to estimate the cointegration model, first I need to run my level variables, a model which will consist of level variables. So I will highlight all these three variables here, so FTSE price, FTSE dividend and R20, and I go to right click, open them as equation. Now I want them in this order. Now constant is added usually, so we will keep it there. Now my sample is defined here, and I will use ordinary least squares, and I will click OK. Now I've got my OLS results here. Now we won't look at them anyway. By the way, I forgot to say, we assume, so I'm not testing them for unit roots. I will assume that all these variables, including the dependent variable, are I1 integrated of order 1, or requires at least, it requires differencing once only. So otherwise you won't be able to use this cointegration approach if you have I0, I0 variable. So it has, all the variables have to be I1. That's one drawback of this model or approach. So we will ignore them all. Now what I'm interested in here, this is the first step obviously, so you run the regression on levels, keep the dependent variable as dependent here and independent variables on here. Now you have the constant here, and all of them are significant, but we do not look at them at the moment. Okay, now what I want from here is the residuals of this model, of this estimation. Now to save them, I have to save them, so I'll go to proc, make residual series, and I'll choose ordinary residual type. We don't choose standardized, we don't generalize. So we will now name it, and let's say I'll name it error correction term, ECT. That's actually what I'm looking at, ECT. Okay. Now these are my residuals from this model. Now basically what this how this residual is calculated. Sorry, this is a simple demonstration here. This I'll show here. Now my ECT is basically equal to dependent variable FTSEAPRICE minus this variable, independent variable FTSEADIV. Now plus, it has to be minus, but since we have negative value here, R20. Now these have to be times by the how do you call this, respective coefficient. So the coefficient here is 23.75, so 23.75 times, now this one is 21.66, 21.66, and I have minus C, which is 198. Well, I leave it as it is, non-significant decimal point. So this is my basically ECT or ECM model. Now this is how the residuals are calculated, and these residuals are here as well. They're the same basically. So the one that I saved through the proc function through here, which is this one, is exactly the same as this one. So let's go further, you'll see that they are the same. I simply saved it through different venue here on, so these residuals are the same. Now to test for cointegration, what I will do is I will run a unit root test on this series. If the residual series, ECT series, are stationary, then the variables here are cointegrated, or they move together. If this series, ECT series, is not stationary, in that case there is no cointegration among these variables. So how do we do this? We will go to view and we will go to unit root test. Now we will keep it as level, augmented decay Fuller test, and leave the default as it is, intercept, Schwarz criterion for lag selection, and press OK. Now you could say we rejected the null hypothesis of unit root and it's stationary. No, we won't do so, because these t-statistic, these values are not valid here. In other words, the t-statistic here is a non-standard or distributed non-standard. So what we do is we will take this, which is minus 3.27, and compare it against a set of critical values provided to us by Davidson and McKinnon. So these ones we'll look at. Let me widen it so that you will also see. So this is the table that we look at. We take the critical values. So, and this paper is available on the internet in journal database, or it's available in a book form as well. Let me read it. It's the name of the paper is titled, sorry, Critical Values for Cointegration Tests by Davidson and McKinnon, 1993. So you could search for it on Google to get the table, and it's table 1 in the appendix. I think it is in the appendix. Let me double check. No, it's just before the conclusion apparently, so you will have a look at that later. Okay, now at 5% level, 1%, 5 and 10% level, and M stands for number of variables, and constant is the constant in the unit root test that we included. Sorry, where did I put my, yeah, here we go. So it's this constant that we put into in the unit root test. Now where did I put my table? Okay, I'll bring it back. So how many variables do we have? We have, including independent variable and dependent variables, we have 3 variables in total. 3 variables, and we included constant. So this is the row we look at. This is the row we look at. Now if you look at this critical values at 10%, the value is minus 3.45. Now what about our critical value here? 3.27. Okay. Right, let me bring it back. Now our critical value is greater, our t-statistic is greater than this, so we fail to reject the null hypothesis at 10%. However, again, we'll compare it against 5% level. At 5% level, our t-statistic is greater than this value. So again, the same scenario, we fail to reject, and at 1% level, 4.29, again we fail to reject the null hypothesis. Now what it means is when you fail to reject null hypothesis, that means there is a unit root in this series, or the series are not stationary. The series are not stationary. That means there is no cointegration among the variables then. Now with this, I hope you learn how to run the cointegration testing using Engle-Granger approach, and I will repeat again. First, what you do is you just estimate your model as you want, like in levels. Usually if you take logs it's better. I haven't done here, so could have done that. And run the test, run the model, and then after the model is run, you save the residuals as you wish, under a different name. Obviously, when I say as you wish, you have to save it on a name that you wish to save it. So I just put ECT, but usually ECT is what it stands for basically, or what it is basically. Residuals are ECT, error correction term basically. Now after doing that, you will then test this series for unit roots. If again the series this series has unit root, or that means not stationary, then there is no cointegration among these variables, among these three variables. However, if there is a if the series is stationary and you rejected unit root hypothesis, in that case variables are cointegrated, so you can run a vector error correction model then. And you can do that manually as well by putting ECT in the model basically, and you can run it for causality, Granger causality purposes, or to find out the causality among the variables as well. Okay, then with this I'll end this video, and hopefully you learned something from this video, and then you will leave comments so that I could improve and the future videos that I am planning to upload later.